All right, excellent. Thank you everyone for coming. It looks like we've still got some folks streaming in, so I'll hold on for just another second or two. Definitely appreciate everybody hanging out. Day two of VM World, and if you're on the East Coast like I am, we're getting towards the end of the day. 4:55-ish. So, Europeans and East Coast folks, thank you for hanging out all day. For those of you on Pacific time and over in APJ, well, thank you as well. But in certain cases, good morning, and hopefully you're enjoying lunch. All right, so 4:56. Let's go ahead and start. Looks like everybody's making it in through the queue there. So welcome to this VMware Code session. My name is Kyle Ruddy. I am a senior technical marketing manager at HashiCorp. However, I'm not here on behalf of HashiCorp. I am here on behalf of myself because I love doing things for the community. I love sharing some of the things that I've been able to do and kind of grasp and understand. I think that that ability to share has really really made me a stronger administrator, practitioner, and so forth as I've gone throughout my career. And that's definitely something that I try to share amongst everybody at events like this. So with that, I have no slides. This is all demo. So let's dive right in. What we're going to be working with during this session is going to be this vSphere environment. So we have a couple things that are set up. I'll kind of show you what's happening here because this is a real environment. It is running right down the hallway from where I'm standing right now. It actually looks like it's cleared up a lot of the errors, which is surprising because normally that's the joke about how do you know this is a real lab because of the error. Oh, look, there we go. That's how we know that this is a real lab. There are errors and alarms and things that are going on. So what we're going to be doing is starting to, instead of our normal standardized, click, UI driven approach, is we're going to kind of twist this into more of a automation focused, declarative based model in terms of how we manage our vSphere environments. So what we're going to be making use of today in this session is going to be Terraform and the vSphere provider. So what we're going to be doing within this environment is we're going to start off by managing folders. Now, I know everybody's probably thinking right now, folders, well, that's not very exciting. However, if you take a step back and think about it from the vSphere, the API layer itself, objects are objects are objects. So a virtual machine is an object, a folder is an object, a data store is an object. All of these things are objects, and those objects exist in the same way to tools like Terraform. So in this case, for folders, they're easy, they're fast, they're very low maintenance in terms of creation, destruction, and so forth. So that's what we're going to be using at least to start off. So let's jump into our Visual Studio Code system that's right here. I have what's known as a main.tf. This is the main configuration file that basically tells Terraform what to do. So we're going to start off by creating a Terraform block. This is just telling Terraform what we want to use to interact with an environment. So in this case, we're using the vSphere provider, and that means that Terraform now knows that it's going to be talking to a vSphere API and a vSphere environment. Then we have our provider block. This provider block is going to be what our credentials essentially are, especially for those of you who are familiar with things like Power CLI and some of the SDKs that VMware and vSphere has. So we have things like user, password, and your vSphere server to kind of, establish that connection. And one of the things that I want to call out that's happening right here is this little pop-up block here that's vSphere server optional string, and this is the vSphere name for the vSphere API operations. This is all happening due to IntelliSense that's built into Visual Studio Code. So this kind of helps us, as well kind of grasp what's happening in the code that we're writing and creating to manage our environment. Other tools that are out there like Sublime Text has their own version of IntelliSense and so forth. So if you're using something like that, look for those extensions. But then let's jump down here to the actual objects and resources that we're going to be making use of and managing. So there are two different types of resources when it comes to Terraform. The first one is the data resource. And what the data resource is it's think of it as like a read-only resource. It's something that Terraform knows about, but it's not going to be managing. We're not going to be making changes. We're not going to be removing it. We're not doing anything about it, but Terraform knows that it exists. Then we have our resource block that's down here, and this is going to be where we are creating our folder. In this case, it's just the vSphere folder type. We're going to be calling it VMworld. In the Terraform world, this is known as the path. This literally lines up to what that path is within the vSphere client. Now, the other important thing that I forgot to bring up here when it comes to our data block here, when it comes to Terraform and interacting. Oh, no questions, just errant unmutings. So when it comes to the way that Terraform interacts with all of these things with the vSphere provider, it comes down to this data center. So, if you're familiar with clouds and AWS, Azure, or GCP, what have you, think of these as like regions. This is where you tell your tooling where to point at. Data center to Terraform is the very same thing as like a region. That's the area where Terraform is going to be performing its tasks and looking for those resources to be involved in. So let's actually jump into our terminal session and let's do some stuff. So we're going to start off. I'll just show you, just in this folder itself is our main.tf that we were just looking at. So we're going to start off with a Terraform init. There are a couple different commands. Init is the first one that you're going to get to know, learn, and love. What's happening with this is it's reaching out, it's checking that provider block, and it's going out to the Terraform registry and grabbing back the information or providers that it needs to work with. In this case, it's grabbing our HashiCorp vSphere provider. There are a bunch of different providers that are out there to use and access. If you're familiar with PowerShell, this is very similar to the PowerShell gallery. If you're familiar with other things, this is very similar to like PyPy or any of the other registries that are out there really. So we can see the Terraform has now been successfully initialized. So we're all good from that. Now the next command that we're going to have to become familiar with here is the Terraform Plan. Again, for those of you who are out there that are familiar with Terraform, we're starting slow and then we're going to build up faster into more and more advanced things. So just hold tight if you're already familiar with these. So what's happening with this Terraform Plan operation is it's literally spitting out the plan of what Terraform is going to do in order to get to that end result that we've defined in our main.tf file. So in this case, it's telling us that we are going to have a create action for a resource, and it's going to create that vSphere folder that we defined. Then at the bottom, there's also just a one-liner that spits out what it's going to be doing. In this case, we have one add. So now we're building on top of that, and we've seen that that's going to work okay. Now we're going to do what's known as a Terraform Apply. Now this is a little bit of a change from the plan because we still see the output from the plan. However, at this point, it's going to say, are you sure that you want to perform these actions? Of course, yes, we want to perform these things. This is just a simple folder, so it's really easy to see and visualize here. So if we switch back to our vSphere UI, we now have a VMworld folder that was just created. We can even see this down here in our recent tasks. We can see that my service account for Terraform was the one that created that. So we're not like sneaking around any of the recent tasks and events to create and manage these things. They still show up as required. So it's still following the vSphere permissions. It's still following all of those, that whole line of thought in terms of how we manage our vSphere environments. So now that was a very simple, very basic way. I don't expect any of you out there to really be creating Terraform configurations to manage just one single folder. Like that's a lot of overhead for something very simple that most folks are familiar with, just like right-clicking new folder. So now let's build on top of this. So we're going back to our terminal session here, and we're going to switch my branch over to, I'm using Git or source control for all of these things, so I can switch in between some of our demos here. So we're going to switch over to a structure. There we go. So now if we check out our main.tf file, we can see that this has been updated to now add in an additional resource by the name of web. And we're even going to put it there. We're going to make a web folder there that's at the end of our previously created VMware folder. So very simple, very basic, pretty straightforward here. Hopefully everybody's following along. With that, we're going to go ahead and do our plan again. So now this time it says that we're going to create an item. In this case, it's that web folder. So we're only making one change. So we're only adding one thing, 0 changes, no destroys. So now we can do our Terraform Apply, and we're going to skip ahead here and do the auto approve. So it doesn't prompt us for yes every single time. All right, so now we can see that our folder has been created. So if we go back and jump into our vSphere environment, if we expand this, we should now see our web folder. Success. Great. Now let's take and kind of focus on another one of these Terraform actions here. In this case, we're going to do a Terraform Destroy. So this is basically the cleanup. So we've done the plan, we've done the apply, and now we're doing a destroy because we want to clean up all that infrastructure that we created. So here we still see the output of our plan. We see that we're going to be performing a destroy task. It's going to go against our parent folder and our web folder that we created that are out there. And again, that one simple line there is saying we're destroying 2 things. Now, one other thing I want to call out here, and this is kind of the power behind declarative code and how this all works, is that like we don't have to tell it the order. Like we don't have to tell it to destroy web first, then destroy VMworld. Like Terraform manages all of that for us so that we don't have to. So simply by hitting yes, we're going to see that we see some delete folders going on behind us. And it takes care of that for us. We don't have to worry about the order. We don't have to worry about any of that. Then we can go right back in, do another Terraform apply with the auto approve. And we can see that our VMworld folder has been created again. And we now see our web folder. Simple, straightforward. Hopefully everybody's still with me. We're now going to introduce this notion, this concept of modules. So this is how we kind of turn this. Actually, I think I got ahead of myself there. We're going to take a look at variables now. So, everything there that was in the code, this is all static based, so we told it specifically that we want it to be VMworld. We told it specifically that we want it to be a web server. So now we're going to think about repeatability, being able to kind of pivot our code into other areas, maybe not just VMworlds, but, maybe other conferences or other areas or regions, whatever works within your environment here. So we're going to switch our branch over to our structures variables. So variables are exactly the way that you expect them to work, just as they do in pretty much every other language and in every other fashion. So we've gone ahead and changed some of our inputs here over to variables. All you need to do is call them out is just var dot whatever the name is. So in this case, we have var dot username for our username, password, vCenter. We've added the name to our data center in case we're working with a vCenter server with multiple data centers. And the same thing for like our folder. And then we've also gone ahead and built out that structure to be something that more resembles a little more real world scenario that I had to manage at one point in my career where, every single time we stood up a new grouping of folders or a new grouping of workloads, it was a, certain particular set of folders that went along with it as well. So now let's check out our variables file here. So what our variables.tf file is doing here is just basically defining what the variable should be. Now we could get extremely verbose and saying things like, our username, we want this to be, of a type string. We could give it, or we have given it the default. This is just the default value whenever it's used. If we don't specify it otherwise, it's going to use what's here. We can also do some variable validation that is way above and beyond what we're going to cover today, but definitely check that out if you're interested. So in this case, we're going to go back to our code here, and we're going to do another, let's just jump up, do the apply and the auto approve. So we can now see that some of these additional folder structures have been created and added to that existing VMworld folder. However, the one thing that I do want to call out, this was a bit of a typo on my end, but it works in the demo here because this last resource that's being created or managed, this is the web folder that I originally created. And if you'll notice, this is, it's focused on the user case or not user case, the capitalization here. So it was web with a lowercase w, and now it's web with an uppercase W. And we can see that it's being updated in place. This is another one of those situations where you kind of want to understand exactly what's happening. That's kind of an automation thing in general, not just for declarative code and tooling. But that gives you kind of a good understanding of what's happening and in what way it's going to be changing. So with that, we have those. Dive into our management folder because we built out those as well. So we have Linux, VMware, Windows, all those sorts of things. Now we could also take use of our variables by now. Let's change the VMworld variable, our parent folder. So I'm going to cheat here and pull this from my script over there. So we have Terraform Plan, but now we're going to supply one of those variables that we defined in that variables.tf file. In this case, it's going to be our parent folder. So instead of being that default of VMworld, we're going to change it to Tampa because that's where I live. So now going through the planning process, it's going to change all 8 of those things. So now we can see instead of VMworld Web, it's going to be Tampa Web. Instead of VMworld, it's going to be Tampa, and so on and so forth throughout. Then we can also go ahead and go through that and simply by, again, changing our plan over to an apply. We have the auto approve on the end. And this is going to be one of those areas where it's kind of an interesting thing because it's like a chicken and egg type scenario. So we have some errors that are here, in which case it's like, oh, wait, that thing, VMworld changed. We can't find it anymore. What's going on? And this is, again, chicken and egg type scenario. But if we notice back here on our vSphere UI, everything changed just fine. Everything's good, ready to roll. If we do another plan, there's no changes. Everything's good. Everything's solid. We're set. So keep that in mind as well. Some of that comes down to the way that the tooling is written. Sometimes it comes down to the provider. Sometimes it comes down to the environment that you're working on. But in this case, it was successful. It does work, but that does give you kind of an understanding of what the output looks like, what an error looks like, should I say. All right, so now we're going to move on to modules, since we're coming up at just about the halfway point. So we're doing pretty well on time. So modules is another way of kind of changing the way that you use and call your Terraform code. So it's really mainly looking at repeatability in terms of that. So what happens now is instead of that huge giant block of code that we had to create, maintain, and update, we now have a very much simpler main.tf file. So in this case, we've taken all of that block of code and condensed it into a module. So now we just call it using this module block. Now we still have that input here of our parent folder. So like literally we're using the exact same code as before. We've just put it over into a module. And so what's happening there is we've created our modules folder, then we've given it a folder name. So vSphere folder structure, and that lines up with exactly what our source here is. It's basically telling Terraform where it should find this module, where it's living at. This is another one of those situations where you could use the Terraform registry to pull down modules that have been publicly shared. However, this is just a demo, so I don't want to share that with everybody, although I will share this on GitHub after the session's done. So if we pop open our main.tf file that's in our vSphere folder structure, we can see it's exactly the same. We have our data center that's there. We have our parent folder that lines up to our variable there. We have the web folder, databases, file servers, management, and all the folder structures that's beneath that as well. So nothing's really changed from that aspect. So let's jump back into our code here. And one of the things that we have to do is, because we're using a module, we have to tell Terraform that it needs to be aware of that module. So we're going to do another Terraform init to initialize that. Here across the top, it says that it's initializing those modules, and it has found it in our vSphere folder structure directory. And then at that point, it also says that we're continuing to using that vSphere provider that we downloaded previously. So we're not reaching out every single time that we run a command to do stuff. So now we can do a Terraform plan. In this case, it's literally the same code. We're going to add 8 new things. Nothing too crazy going on here. So let's go ahead and roll that out. So we have our VMworld folder back. We can see that our task there just finished building out. So we have our Linux, VMware, Windows folder. So let's again build on top of this, because I know a lot of you who are watching this are like, yeah, but this is cool, but when am I going to use it in my own environment? And because a lot of folks are using brownfield environments. You're very lucky if you get to see a greenfield environment from day 0. So what Terraform can do is we can import objects as well. So what we're going to do is import this code 2755 folder, which is the name of this particular session. We can do that with the Terraform Import command. So let me show you exactly what that looks like. Okay, so jumping back to VS Code, we can now open up our main.tf file. And we have populated it with something that looks very much like the way that you create a folder, because that's essentially what you're doing. You're telling Terraform that this folder exists out there, or rather should exist out there. It should be managed. It's this name. It's at this path. So, looks and feels very much like Terraform in terms of the way that you create things. However, the change comes when we take a look at our actual code here, because this one is a little lengthy. I have that on here as well. So what we're doing here is we have our Terraform. We do an import. It'll stop and highlight only one thing, and then we tell it exactly which resource that we're going to be importing. So this vSphere folder code 2755 lines up exactly to the one that we defined right here. So we're telling Terraform to import a resource, and we want it to be this one that we've specified in our code. Then at that point, we tell Terraform where it exists in our vSphere environment. So in this case, it's going to our data center, to our hidden VM folder that's out there, and then it's that code 2755. So at this point, if we hit enter, we're going to see that it's preparing to import that folder. And it's going to refresh our state, which we haven't talked about. So let's get into that here in just a second. And it says import successful. So in theory, we should all be all good to go. So now let's talk about state. So this is kind of something that is out there. It exists. It's this terraform.tf state. And we also have a tf-state.backup. So just in case something happens with the Terraform state file itself, we have a backup. So this Terraform state file is basically Terraform saying, this is what we understand that this environment is, what it looks like, what we're managing, what we've been told about, so that it doesn't do anything crazy. It doesn't react in any way or form that way. Plus, that means that it doesn't have to reach out to the environment and learn everything all over every single time. So it makes it a little on the performance side as well. Now, what we're going to do is take a look at that folder that we just imported it and see what that looks like when it comes to the Terraform state side. So Terraform also has this state command as well, where we can say state list. So here we have all of those different folders that we've been creating and managing this entire time. Then we also have this vSphere folder.code 2755 there at the top. That's the one that we just imported. So then if I'm going to take out my longer code there again. So if we do a Terraform state show, this is going to take out one particular resource that's in our state file and output that to our screen, to our terminal session here. So we could see that there's things like custom attributes that we could be entering and specifying if we so chose. Same thing with our tags. Same same way, same path as how that all works. And we can see that for all of those different items, all these different resources that are contained within our Terraform state. So now we're going to go back and instead, we're going to destroy it, because why not? So we're going to do our Terraform Destroy, auto approve, so we can see that it's destroying all those 9 things. And we see at the bottom here that it's destroyed 9 things. So going back to our vSphere UI, we see that our code 2755 folder is gone. We can see that our VMworld folder is gone. So it imported that, and now it's a part of what Terraform knows about and can manage. So going back, that also means that if we hit our Terraform Apply, it means that it should also come back. So now we can see that code 2755 was created. We also have our VMworld folder. We also have our Linux, VMware, and Windows folders have all come back and been made available. So at this point, that's basically a lot of the things that you can do with folders. So let's move on to virtual machines, because again, object is an object within the vSphere environment. So let's take a look at how you would do that, because you're probably going to be managing virtual machines on a more common basis than you are folders. So what we're going to be doing is switching our repositories here. We're going over to this vSphere deploy directory. And so in here, we have a very similar layout. All of this should look and feel just the same way until we get down to where we actually define what that virtual machine looks like. So we have our vSphere provider again, we have our credentials, we're using variables, then we have our data center. So all of these things feel similar. Then we get into, when you create a virtual machine, there's all of these different areas and items that you can choose and manage when it comes to that virtual machines. But we also have to tell it where it needs to live. So we're using the vSphere resource pool. So we want to put that into a resource pool. We're going to put it into a particular cluster. We're going to put it into a data store. We're going to specify the network. We're going to specify the folder that it should live as well. And keep note, as I'm going through here, all of these are data resources. All of these things are stuff that we want Terraform to know about, but not manage. Now, we don't want to change anything about our folder structure in this one. This one is all about the virtual machine. Then we get down here to our resource block. And this is where we're going to be managing our vSphere virtual machine. In this case, we're calling it dev VM. When it comes to the Terraform side of things, we're giving it a name, telling it resource pool, data store, folder. Notice all of these things are ID based. So that's also another reason why we use the data source to import that by name. And then we can provide the ID to the virtual machine. We're going to give it a number of CPUs, memory. We're going to tell it that we want it to be CentOS 6. And we want it to have I believe that's 20 gig disk, not 20 megabyte. Let's see, does it? Oh, there we go. IntelliSense at work, size of the disk in gigabytes. So we want it to be a 20 gigabyte disk, and we want it to live on one particular network interface. So, very granular. There's a whole lot of options that come down to a virtual machine, and that's kind of why I didn't start off with that as our example. So switching our folders here. Not clear. So here we're back to this. We have our main.tf. We have our variables file that contains all of those variables. Not worth going into that at this point, since we're about 6 minutes until we run out of time. So let's do I believe we have to do another initialization, grab our vSphere provider, and do another Terraform plan. So here we see the output of exactly what makes up a virtual machine when it comes to Terraform and the vSphere API. So there are a lot of things that are going on here, number of cores per socket, SCSI IDs, SCSI types, HV mode, guest ID, default IP address, all these different things that you could assign if you so chose. But for the purposes of this, we don't. So we don't create those things. So at this point, we're ready to do a Terraform apply, and we're going to do another auto approve. So now if we jump out into our environment out here, we can see that we now have a demo VM. That was what was assigned in our variables file as the default. It also lives out here in our VMworld folder. Now, this is just a shell VM. If you'll notice, I didn't specify a template or any other virtual machine that it should use to clone, because again, time is of the essence when it comes to this session. So we could see things. Oh, the other thing that I want to call out, if you'll notice, not only did it create the virtual machine down here, but it also powered it on. That's kind of how Terraform works. So just have that understanding of it's kind of a workflow that's going on here. It's going to create the virtual machine, it's going to turn it on, and it's going to be basically ready for you to use. Now, the other thing that I want to show off here is what a destroy looks like. So let's go back up, and there we go. Terraform Destroy. We're going to do an auto approve on that one again. So theoretically, it's going to see that virtual machine. It's going to figure out what it needs to do to destroy it. So in this case, we can actually see that it powers off the virtual machine, then it deletes it and removes it from inventory and deletes it from disk. So now we're going to jump ahead. We're going to go back and embrace the concept of modules here again. So let's switch over to here. So we're going to do our module. So again, it takes that, I don't know, I should have looked at how many lines were in there, 50, 60, 70 lines of code, and condenses it down to, basically the equivalent of 3. So again, we have our module, we're specifying our source that lives out in our modules file right here. And then we've taken all of that code that existed before, condensed it into our vSphere empty VM module. So we can see, still have our vSphere virtual machine that's out here, still using CentOS 6. Now, the one difference that I'm going to call out here, because this is going to be important for the next part, I'm making use of a different provider here in order to randomize the name for this virtual machine. So for this, we're going to see a couple different things happen when we do a initialization. So here we have the initialization of our module. Then we have the initialization of our random provider. So let's do we are so close to time, so going quickly, we should see that now we have created a name, and now we have a primary Joey 01 virtual machine that's been out there created. This time it's been put into our home lab because we changed that as part of our variables. So it doesn't really matter where it lives, can live literally anywhere. So for our last trick here, I want to take the module and really kind of show you the power of what's going on with these modules. So if we look at our main configuration file, we have this notion of count. We can do things like different functions. So we can do a count, we can do a for each, we can do different style of loops so that we can create multiple virtual machines or multiple different objects in whatever way we choose. So in this case, I want to change our configuration here, and I want to create 5 different virtual machines. So here we're going to rip through there. So there we go. So now if we jump back to our vSphere environment, as we come right down to the last minute, you can see that we now have a enjoyed Pika, a smashing ape, a suited heron, and a sunny hippo. And then, we can continue to kind of update and change things as it goes. So if we, say, okay, now we only need 4 of those things. If we do a Terraform apply, it will at random remove one of those. So in this case, it's saying destroy 2 things because again, we're generating that randomized name and then destroying the virtual machine. So if we go back to our vSphere environment, we have destroyed our enjoyed Pika. So with that, that is what I have. If you enjoyed some of this, hopefully you kind of see the power behind declarative code and the way that it can be used to really enhance your management experience of vSphere. I definitely highly recommend checking out the HashiCorp Learn site. It's just learn.hashicorp.com. There's a Terraform section And in that Terraform section, if you go to machine images, there is even a manage VMs and snapshots on vSphere. If you're kind of curious on how you can build out the template to get to that point, there's even a provision infrastructure using Packer that can kind of help automate the creation of your like golden templates. So with that, let me hand it back over to our lovely VMware code team as we kind of wrap up the session here.
How are you using Terraform in your day-to-day? I see that.
Day to day, I use Terraform a lot in especially demos such as these. Terraform is great because it's kind of one of those things of like, instead of in this kind of declarative way, instead of having to learn about the services, you can learn about the tool and then pivot your usage of the tool throughout the different areas. So if you can create a virtual machine resource, there's a good likelihood that you can transition that over to AWS and create an S3 bucket or an EC2 machine. Same thing for Azure and everything else. Let's see. Yes, this is the pandemic do. This is what happens when going to the barber is an interesting experience. How can we use the API to call Terraform to deploy vSphere resources? That one is what happens when you use the provider. So there's a tremendous provider ecosystem that's out there. VMware actually does a really good job at creating providers. So there's things for vSphere, there's a VMware Cloud on AWS provider, there's NSXT, there is what is vCloud Director, I believe, has one. There's a whole bunch of stuff that are out there. And that basically is your gateway from Terraform into calling and using the those services APIs. Is Packer in addition to Terraform? Absolutely. Well, in vSphere land, yes, absolutely. So kind of think of it in the way that Packer is going to use the same language, HashiCorp configuration language, or HCL, underneath the covers in order to create and build resources. You can do that same, you can apply that same concept into the way that you generate your templates and images and things of that nature. So that's another one of those areas of hey, once you understand HCL and how to deploy resources and infrastructure, you can kind of pivot that over into Packer to start also automating your templates in that build process as well. The IntelliSense extension was the Terraform. It's HashiCorp Terraform extension. It's available in the VS Code library there. I see Kaylin's out there to answer some of these as well, so apologies for repeating some things. One of the things that you'll notice, as you use HashiCorp tooling, you're going to see a lot of HCL. So that was one of the transitions for Packer from JSON to HCL. It's something that you'll see in Vault, in Nomad, in all the different tools. So it's kind of nice from that aspect that allows you to switch in between with fairly minimal impact. Let's see. Looks like a couple of people called out, but it's worth repeating. Auto-generating Terraform code, that is not something that happens today. That is something that I had to pre-create in my configuration file and then tell Terraform to import it to that specific resource. That is definitely something that we've heard a lot of, putting on my HashiCorp hat. We've heard a lot about that, a lot of requests. So that could be something that you see in the future. But again, that's not something that's available today. Single Terraform files, there's no limitation on what you manage. If I wanted to use a single configuration file to manage my entire VMware environment, not just vSphere, but VCD, NSXT, VMware Cloud on AWS, vSphere, I could totally do that if I wanted to. At that point, it kind of comes down to what your focus is. Because at that point, you're going to be starting to spread out who is managing that infrastructure amongst maybe, team members, if not multiple teams. So think about the way that you consolidate the configurations in that kind of aspect. But yes, totally possible. Yes. using Terraform to stand up a VMware cloud environment was absolutely one of the scenarios that was thought of and really focused on, because that's, if you think about it, if you've ever deployed a VMware cloud on AWS environment, that's kind of a time intensive thing. Whereas, instead of logging into the UI and going through that process, you could just tell Terraform to, go and do the thing. And then when it's done, you have your VMC environment up and running. So yeah, that's totally one of those things. The providers and the APIs have gotten substantially better over the years since that's come out. So, absolutely, that's definitely something that, a goal of taking whatever way that you want your VMC environment to look, and then being able to, create that through Terraform. So I see a question about changing resources. It kind of depends on what it is. So there's some logic built into Terraform in the way that it kind of determines what's happening. So like if I went back to my shell VMs that I created in there and told it instead of one CPU, I wanted them to have two, it would be a change operation. If I wanted it to change names, actually no, changing names might be a change as well. There's a couple different things that if you do it, it'll actually go through and destroy and recreate. So that's definitely one of the important areas of understanding that, transitioning between the plan to the apply process. And yes, it can do cloning operations. That's definitely one of the very high level things that that I've used it for myself personally in, my past admin experience. Taking that golden template and cranking out virtual machines or multiple virtual machines based on those templates. ESXi management is extremely limited. And some of that comes down to, again, kind of the chicken and egg scenario of, some of it you have to have a vCenter server that's up and running in order to, do like cluster things, setting DRS rules, things of that nature. So there's limited functionality that's there. This is definitely not an area where you could like use Terraform to replace auto deploy. I would definitely not do it for that. So sweet. I think I've answered a majority of it. For the folks that are still here, if you still have questions, definitely feel free. I'm on the VMware Code Slack, definitely available on Twitter as well. So, definitely feel free to reach out with questions or follow up or anything along those lines.